Hello, everyone. I'm Zhuoran from Antipolis University. Yeah, also as the organizer, I will present the first submission for the pixel privacy task. Yeah. As Martha has just introduced to you, the main aim of this task is to protect the image privacy against large-scale inference. And at the same time, we want to keep the image appeal, or even we want to improve the image appeal. We don't want to, when you share some social images online, you don't want to destroy it. Like you don't want to add some pixelization or a blur on your faces. So based on this idea, we proposed two categories of approaches. They are a perturbation-based approach, which is focused on the protection part, and style transfer-based approach, which based on the improved image appeal. After introduce the approaches, I will show you the performance evaluation in two parts, also in both the privacy and image appeal. In the end, I will make the conclusion and talk about the future work. Also include the questions as for the generalization for other classifiers. Yeah, the perturbation-based approach essentially is one kind of way to generate adversarial examples. Now we in this submission we use the work from adversarial perturbation for the universal one. Given a data set, we will use the knowledge of the model to train one perturbation vector. After adding this vector on the original image, we will get one perturbed image. You cannot see here very clear, but if you zoom it, you will see some artifacts on the image. Generally, this technique works quite good, but it has some drawbacks. The first thing is, if you want to train it, the model information must be available. If you want to break the ResNet we just showed you, you have to know the exact information, how you pre-process your data, what is the structure of the network, and what is the weight. You have to know everything. So this is the first drawback of this approach. The second one is pre-processing may have a large influence on the protection. For example, you generate this perturbation vector, you add it on the original image, but when you do the classification, you only crop the middle part, then this thing may also lose its function. It cannot protect it anymore. And the third thing is, as I just told you, the image quality is not good because of you add some small values on the original image, so you can perceive some artifacts on the image. The good thing is, compared with the visual privacy task before, the good thing is, as a human, I can still perceive it, but we didn't destroy anything. So generally, it's a good approach. But based on the drawbacks, we also use the style transfer-based approach. Here, we mainly use GAN-based, like a style transfer GAN, to transfer the style of the image. Because, for example, if you like the painting of Monet, we can transfer your image to that style. The schema behind the GAN-based style transfer is you give a target a domain of the images and train your GAN on it. Then you can change any image to the certain style. It's good. Here I show two examples. The leftmost one is the original image. In the middle is one from the cartoon GAN. With a style for Japanese cartoon Hayao. And the rightmost image with a style Japanese painting Yokioi. And you can see from the slide that it has comparably nice quality. Yeah. With these approaches, we made our submission and got some feedbacks for both the privacy and the image appeal. You can see for the test set, original image has almost 60% for the top 1 accuracy and 88 for the top 5 accuracy. After the two are the style transfer, Hayao and Yukioi, we have decreased. Also, the perturbation approach has decreased to 45. it means our approach helps. But one thing to comment here is this did not decrease as we expected too much. The reason there are two reasons. One thing is we have only 3,000 images to train our perturbation. From the original paper is far from enough. The second thing is there may be different pre-processing approaches used. For example, if I generate my perturbation vector already, but you crop it, it will lose some function. This is for the accuracy part. For the image appeal part, we have there are two ways to give me feedbacks. The first thing is we use a convolutional neural network, Google NEMA, to give your aesthetic score. The score here shows like the score is from 0 to 10. If we treat the original images as 0, we can see our Hayao has an increase of 0.6 and Ukiyo-e has a little bit decrease. Except NEMA, we also have we also get a feedback for the user study. To be honest, it's not good. All of the users don't like the enhanced images, but we also need to fix our methods. I'm gonna show you some examples of our submission images. The first one is I think it's a good one. The leftmost is the original one. In the middle is Hayao style, and the rightmost is Ukiyo-e. I think it transfers properly from one style to another style. This is the thing people should like. The second one shows fail examples. In the middle, the cartoon gun has a bad performance on the texture, especially on the edge. And also, the Ukiyo-e with the cycle gun has some texture error on the water. Another example about it is the original image is a snow, but we can see that the style transfer GANs may not deal good with the colors. It has errors with it shows the snow a little bit green. This is what we don't like. Depending on this thing, this is all of the submissions we have done, and we got some conclusions from it. The first is the perturbation-based approach. If you do it exactly right, you know all the information, you have enough training images, it's a very good approach. But the thing I just said is also its drawbacks. If you don't have that, you cannot do it. The automatic style transfer-based approach, you don't need to know any information of the classifier, but you can still have a nice performance for protection. For the future work part, we want to mainly do two sides. For the perturbation-based approach, we want to use some data augmentation methods to train the perturbation, let it have a nice generalization performance. And we want to also find something to fix the problem of preprocessing. For the style transfer GAN, we want to improve the privacy performance because we just transfer it now. We don't do anything about the privacy. And also, we want to fix the errors happened in the edge and in the color. Yeah, this is our approach.